I'm audible. Hello. Hello. Good evening, everyone. Hello. Okay. Not audible. Okay. Hello. I'm audible now. Hello. Good evening, everyone. Hi, everyone. Good evening. I'm audible. Not audible. Okay. Hello. 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 Okay. Very low. In that case. Okay. Now voice is clear. Okay. So good evening, everyone. And today I'm going to take up from there where we have finished in my last class. And as you know that I have started Verilog with the help of the digital design. We have finished adder part. So my idea is to start with the Verilog because in parallel, along with the digital, we can start designing the digital components or digital circuit with help of Verilog. Okay, so this is what exactly my approach. So in my last class, I have explained everything very clearly that how to start basically uh, Verilog. I have discussed some theoretical part. I have discussed the disadvantage available with the hardware design and what is the overcome or what is the advantage of the HDL over hardware design. I have also mentioned that what is the limitation of HDL or Verilog. Then I have also informed you that who is the founder of this Verilog and what is the proud moment for this. Second, with help of Verilog, who has getting the benefit, like the company which acquired the Verilog, and how the Verilog basically become the standard language. Okay, so let me take you to the PPT. Okay. Okay, so this is what we have discussed in my last class. We have basically, I have, we have basically defined the, uh, defined the half adder. Okay, this. So we have defined the half adder, but we have defined with the help of the clear. Okay. So today I'm going to tell you the complete code of hardware design of full adder, how we are calling the half adder in full adder, and how we are calling the full adder to make a 2-bit adder. Okay. So before that, I will first again write a code of the half adder. Okay, so that it will be easy for us to understand. Okay. So for that, please you have to give me some time. Okay. So first, I will design the hardware. Okay. Why I am using the AND gate? Okay. Because I need a clear logic. Why we need a clear logic? Because we need to make a sign calculator. So I am designing the same circuit which we have designed in the hardware design. Okay, this is my A, this is my B, and this is my clear. Okay, and this is my sum and C out. Sum and C out. Okay, so in Verilog, we first start with the keyword module. Module. Then the identifier, half adder, clear. Okay, this is my user identifier. Okay, then I have to write my output and input, so sum and cout and A, B, and clear. Right. So what I will do, I will just to make it best documentation part, I will write the keyword with the on blue lines. Okay. So as we know that we only know that this is my output and input. Okay. Tool don't know that this is my output and input. Okay. So now I will define my output. This is my output. This is my input. Let me write it output and input. Output is my sum cout. We are writing the first code. Okay, so you don't need to worry. We will go up to the behavior modeling. And input is my A, B, and clear. Clear. Okay. Now I will call the gate. Now what is this is called gate level modeling. Why it is called a gate level modeling? Because we need to call the gates. Okay. So gate in my design. So let me call those gates. So gate number 1, 2, 3, 4, 5, 6. I'm writing re again because we need it. We need it in my design. Okay, so now I will call my gates. So I will call 1, 2, all gates. For that, let me write in this way. So I will call my first gate and this is my AND. Okay, I will not mention AND 2, AND 3, AND 4, AND 5. I will simply call a AND gates. Okay, and then this is my instance name. It can be any name. Okay, you don't need to worry. It can be any name, right? And one, and then bracket open. The first will be my output. Okay, I forget to mention the wire. Okay, so I forget to mention the wire. So we need a wire also, and wire is a keyword. Okay, it's a syntax. So this is my wire W0, W1. So what is wire? As I mentioned in the last class, the signal between the input and output is called a wire. The signal which is not connected directly, to any input, the signal which is not connected directly to any output is called a wire. Okay, the intermediate signal, interconnect. So wire W0, W1, this is W2, okay, and this is your W3. See, this wire is directly connected to clear, so not required. Wire W0, W1, W2 and W3. Clear? Now I will call the gates. Okay, so first gate, and so let me call all the gates, okay, just to save the time. This is my AND, this is my AND2, okay, this is my XOR, okay, and this is my AND. Okay, so now let me, so this is my N1, okay, means gate 1. You can write anything, gate 1, okay, this is your instance name, this is your branch name, okay, instance name. Now first is the output. The output of this AND gate is W0. Input is A and another input is clear. Okay, semicolon. Then the output of this AND G2 is W1 and input is B and clear. Right? And again now this XOR. Output of this XOR is G3 is my gate, W3, and then what is my input? Sorry, input is W0 and W1, W0 and W1, W0 and W1, and this is my AND4. This is my AND4, G4. What is my output? Output is, sorry, W3. Oh, sorry, I mentioned here wrong. This is my W2. Sorry, this is my W2. W2. Okay, this one, and colon, comma. This is gate 4, W3. Okay, W3. And now what? What is my input? W0 and W1. W0 and W1. Correct? Now I will call this gate number 5 and 6 here. Okay, I will call gate number 5 and 6 here. Okay, so this gate 5 and gate 6. So gate 5 is when you are writing the code in Verilog. Okay, so basically all the keywords, all the important keywords, basically it's always denote in a different color. Okay, and all the identifiers like user defined, it's always in a black color. Okay, later on after some time I will show you how to write the code, okay, in a tool also. Okay, so let's write it 5 and 6. So and G5. Okay, so output is sum, sorry, and we delete this line, and G5, this is G5, output is sum, input is W2 and clear, W2 and clear. Okay, and this last one again, and G6, the output is sum, is a C out, output is C out. Okay, and what is my input is W3 and clear, W3 and clear. Okay, and that's all. And module, and module. So this is how you write the code. Okay. Now let me write the code on tool simultaneously. Okay. So for time being, we are going to use the same tool. Okay. We are not doing this design on Vivado. Why? Because if we are going to use the design on Vivado, okay, then we have to switch from schematic to Verilog. Okay. So what I will recommend you currently. Okay. My screen is visible to everyone or not? Okay, let me switch. Okay, so I'm switching from screen to my tool. Okay, so again, I'm going to mention here we have to use the same ISE tool. Why? Because we need mm, like like we need the logic. Okay, we have to basically convert uh, this half header with clear in code. Okay, so that is why I'm not going to switch my tool. Okay, I will be on the same tool. If I'm going to switch the tool, then it will be tough for you to manage both the tool on same system, because both tool will take too much space. Okay, so Vivado is also taking too much space, and Xilinx ISE is also taking too much space. To learning the Verilog up to the behavior level, unless until we are not designing at very high scale, this tool is very much enough. Okay, so what I'll do, I will open another ISE, and I will make another project. Wait. So I have opened two ISE in parallel. So, but I can change the project. Okay. So in one ISE a different project and another ISE a different project. So as I mentioned that I am working on HDL side. So I will make another project, and here I will write it HDL Verilog. Okay. You can do both the design, both the things on same project. Okay. Don't need to worry. So here you can change from schematic to HDL, then move to next. And as I mentioned in my first second class that you have to select your device. Okay, this is the device which is available on FPGA board, either a Basis, Nexus. Okay, so we have a Nexus A7 board, so I will use the uh, uh, in that Nexus A7 we have a RTX 7 device, same configuration, 7A 100T. XE means Xilinx Corporation, 7 means version 7, A means RTX, 100 means 100K, T means transceivers, CSG means chip scale grid array package, 324 means 324 IOs. -1 to -2L is basically a speed grade of my device. Okay, and then I am selecting the Xilinx synthesis technology for Verilog, and simulation is my ISim, and then preferred language is Verilog. Okay, so that's all, and say yes, yes. Okay, so I will write the first code which I have written here. Team, I am going very slowly because my objective is not to take this as a syllabus or this as a course module to finish it on priority. Okay, so while writing the code, you have to select the Verilog module. While writing the design, you have to select the schematic. So I will write my HDL, sorry, half adder with clear. Okay, next. Okay, just skip it. You can write your input output, but don't require it because we want to write our own input output. Finish. Okay, so I will increase the size so that it is visible to you. What I will do, I will delete all this. Even I can delete this also. Okay, not required because I want to write from my own. Okay, okay, so I will write my own code. So half adder. Okay, again, this is case sensitive, so you have to write it your own in lower case, lower letter, okay. And you can do documentation. My first code on Verilog. Okay, so you have to use this backslash forward slash 2 times. Okay, this slash 2 times. Okay, to make it comment. Okay, you can use this slash for the comment and then start writing. Okay, so module. See, as I mentioned that whatever the keyword, it show the blue color. Module half adder underscore clear. Then you have to write your input output sum cout A and B and clear. Okay. Then if you all remember this code, okay, the code I have written here. Code I have written here. Code I have written here. I will write the same code here. Okay. I will write the same code in coding in that tool. Okay. Let me switch again. Okay. So I have increased the font size. So I will take the reference of the same code, same design, right? So okay, I will write the same code. Don't worry. So let me first define the wire. So how to name the wire? I can name the wire this. This is my W0, W1, W2, and W3. Okay, make it 40. And test value is W0 like this, W1. Just for your reference, I am writing wire name W2 and W3. W01, W2, W3, oh sorry, 40, W3, correct? Okay, so I will use the same nomenclature in my code. This is my code. So here basically I have used okay, I have used basically sum, C out, A in, B in, clear in. Okay, so I will use the same nomenclature, A in, B in, and okay, A in, B in, A in, B in, and clear in. Okay, so now you have to call my half adder output. Output is my sum and C out. Input is my A in, B in, and clear in. Right, then you have to define wire W0, W1, W2, W3. Even we can write the wire, because the wire is a multiple, okay, with the same name, but in bitwise. So if required, we can also write a wire like this, wire uh, 0 to 3, okay, W. We can like this. Okay, we can basically write in this format also. So later on I will show you, okay, how to use, where to use, when to use. But currently, as we are going through very basic book by book, so I will write it uh, all the wire in separate numbers. Okay, so now I will call gate one by one. So and G1, okay, if you all remember. Okay, so first is W0, W1, and W2 and W3. Okay, G1, G2, G3, G4, G5, and G6. Okay, for your information, I can write this. Okay, like this. Okay, so you can't imagine how this tool is going to help you. Okay, G1, okay, G1, G2, gate. Okay, G3, G4, G5, and G6. Okay, G6. Okay, so I will now call G1. Okay, here I am calling a small letter. There I have mentioned everything in capital letter, so you don't need to worry. So first is W0, W0. Then your input is your input is W0, and sorry, this gate G1. Output is W0 and input is A in and clear in. A in and clear in. A in and clear in. Okay, then similarly and G2, W1, comma, B in and clear in. Okay. Oh, one semicolon, one bracket I forgot to mention here. Okay. Then we have XOR G3. Okay. The output from XOR is basically W2, and the next G4 is W3. So W2, W2. Okay, and you have a W0 and W1. Okay, and then again we have a gate G4. output is W3, W0 and W1. See, this gate W3 output and input is W0 and W1. Okay, W0 and W1. Okay, this one. Okay, and then we have another gate G5. The output is sum. Okay, and the input is W2 and clearing. W2 and clearing. W2 and clearing. Okay, and we have another gate G6 C out, W3 and clearing. Okay, so and module. Okay, why I want to show you here, because later or sooner everything you have to basically do it on tool. Okay, programming is not a theory, right? I can show you the code on my screen, but later or sooner you have to write a code here. This is a direct coding. Okay, we are not using any logic here. Whatever the circuit is given, we have just converted into the gate level. So there is no rocket science here. Okay, but yes, we need to understand the tool, how the tool is working, how to solve the error with the help of the tool, what are the options we have to use to solve the tool, etc. Okay, so you see here in below, this is called console box. Console, error, warning, and find a result. So sometime what happened, this option is missing. Okay, this option is missing. Sometime what happened, this option is missing. So this option is not available sometime. Okay, so like this. Okay, so students are basically, they are very confused. Sir, I'm getting error, but I'm not able to solve it. Where is my error? What is the error? Why it is not simulating, etc., etc. Because your console box is missing. Okay, so tool is basically telling you that okay, you have designed, but this is the error. Okay, so how to get this tool console box again? Go to view, or go to the panel, and you can bring one by one: console, error, okay, warning. So I want these three options only. Okay, so console give all types of the like statement generated while executing any option. Okay, so now select this, select design utilities, or select user constraint, you or select synthesize. There are many things are available. Okay, so if you are selecting the implementation, you will get the check syntax option under the synthesis. Okay, if you select the implementation, and if you select this code, and then you will find the check syntax option here. Right click, run. It will ask to save the design. Okay, so it will take some. Okay, so check syntax. Check syntax, your green sign is up. Okay, in any case, this is actually I have written the code, so tool is working fine. Suppose that I miss this semicolon, suppose that, and I miss this comma here. Okay, and forget, for example, I have missed this interface here. Okay, suppose that. Now let's see what how the tool react. Okay, so save this. Okay, so see, you will get a error here, right? HA underscore clear V and HA underscore clear V, that is the line. This is your design name. D online live YouTube HDL Verilog. This is my path and this is my file name HA underscore clear dot V, and something is related to this. Okay, that is something I am getting or I have an error related to clear underscore in. So I will click on this and tool will automatically take me to that line. Okay, this is the line, either the error on this line or just above this line. ओके, कभी भी इस जो एरर आएगा वो इस लाइन के नीचे नहीं होगा. ओके, जहां भी आपको ये एरो बटन दिखेगा येलो वन. ओके, सो आइदर द एरर ऑन दिस लाइन और ऑन दिस लाइन. Okay, so you will go to this line. Okay, you will find out, oh, I missed the comma. Okay, and you will again save it, but still there is one error. Again you click on this. Okay, let's see what error I am getting here. Again, either the error on this line or on above, just above of that particular line. So you will see here, okay, the error is, okay, everything is fine here. No, here semicolon is missing. Okay, semicolon is basically missing, and again save it. Okay, so your tool basically then again go and again click on run syntax, check syntax. Okay, okay, so check syntax taking time. Let's see why it's taking time. Okay, see, successful, no error. Okay, but still I know there is a instance is missing. So this is not basically an error, but sometime later on this maybe creates some issue in synthesis. So I will give a name G2. Okay, like this, and save it. So your first code is written. Now go for simulation, select the simulation, select half adder underscore clear, select the design, simulate behavior model, or you can also do the check syntax here also, check the syntax here also, and then simulate behavior model. Okay, I hope this is clear to everyone. Okay, now tool will automatically take you to the simulation. So this is my simulation window. So I will take my all my output in the last and all my input in the top. Okay, so these are my intermediate signals, right? So just to, okay, up to 1 microsecond, right, एक force clock, force constant. Okay, so force constant 0. Okay, B in 1. So if I am giving A0, B1, the output should be 1. Okay, but here I am giving the clear also, right? Clear in 0. Okay, so all my output will be 0 because my clear is active. So I will disable the clear. Okay, I will disable the clear and I will enable it. Then what I'll see here, my sum is 1 and carry out is 0. Okay, and if I give both 1, that means my sum is 0 and carry is 1. That means my design is working fine. Okay, now let's move to the full adder designed with the help of half adder. So basically this is called user defined. Here basically we are calling the user defined. Okay, again, this gate level coding is not help you in developing any logic, but actually this is required, because if you don't know how to connect all the blocks, later or sooner you have to learn this. Okay, writing the code in Verilog is okay, but you have to learn the every aspect. At least you should have a basic understanding. So now what I will do here, I will call, so basically I have designed this half adder. Okay, so my half adder is, the name of my half adder is, half underscore clear. Okay, please remember this. So I will write it. So this, actually this is the library name, half adder underscore clear. Okay, I have designed this separately with respect to the tool. Okay, with respect to the tool. Okay, so what is the inside the symbol? The symbol is same. Okay, यही अभी हमने डिजाइन किया है. अब इसको हम डिजाइन करेंगे with respect to the two half adder. Okay, okay. So अभी हम इसको नाम देते हैं half adder underscore clear. Half adder underscore clear and half underscore clear. Okay, because we have to call now HA, we have to call now my this my clear my half adder device. Okay, okay, this is half adder underscore clear. आपको सीखना पड़ेगा, आपको टाइम देना पड़ेगा. अगर आप नहीं दोगे तो पर्पस सॉल्व नहीं होगा. You cannot make it on fast mode 1.5x, 1.75x. Okay, take your time, finish one video in 1 day, 2 day, 3 day. Okay, now we'll define this wire. Okay, so wire, this is my wire, this is my wire, and this is my wire. This is wire, this is wire. ये वायर होगा एंड ये वायर होगा एंड ये भी वायर होगा. ठीक है, दिस. ओके, तो लेट्स गिव द नेम W0. Okay, W1. If I'm missing anything, please let me know. W2, W3, W3, W4. This is my W5. This 40 is my basically font size. Okay, W5, W6. This one is W6, and this is my W7. Okay. Oh, sorry. W7. Right. Okay. So now let's give the name also of my this all components so that you should have a better understanding. Okay. So this is my gate 1, gate 2, gate 3. So I can write in between also like this also, gate 1 like this. Okay, so this is my G1, gate 1, G2, G3. Okay, this is my G4. G4. G5. G6. Okay, so, sorry. So this is my, I will call this user defined one. Okay, user defined one, U1. Okay, user, this is my user defined U1 and U2. U2. Okay. बड़ा कर सकते हो like this. See, so I'm doing for you so that you should have a better understanding while writing the code. Okay, this one is missing gate 5. Okay, this one is gate 5 is missing. G5. Okay, sorry, G5. This is G6. This is G6. And this is your G7. G7. Okay, correct. So let's start. Okay, so let's start writing the code. Okay, I don't want to switch again from board to here because this switching from board to here and again from system to board, it will take a time, right? So the same thing, if I will design there, it will take time. It is already designed here. I have already shown you the demo in my previous classes, that is in last classes of digital design. I think class number 9, 10, 11 or something like this. Okay, so let's start writing the code of this. Okay, so I will go and I will write the same code. I will do the same thing. New source, Verilog module. Okay, then I will write my full adder FA underscore clear with help of two half adder. Okay, so FA underscore clear. Click next, next, finish. Okay, so here you have to, before writing the code, you have to first understand that what is the position you are following. Some C out, A in, B in, C in, clear it. Okay, the same position you have to map it. You have to use the same position while mapping your input and output with respect to the half adder clear in full adder. Okay, how? I'm going to tell you how. So again, I will write it. I can write it like this. Okay, you can write your own module FA underscore clear. Okay, then then write the top level input and output. So what is the input and output of my top level full adder is A in, B in, clear in, clear underscore in. Okay. So if your name is same, doesn't matter. You don't have to worry. Name is same means the name of the previous component and name of the new component is same. Don't worry. Okay. Sum C out. So it is not going to create any problem. So okay. So sum C out. Here you have A in, B in, C in, and clear in, like this. Okay, A in, B in, C in, and underscore clear in. Then output, your sum and C out. Input, your A in, B in, C in, and clear in, you have to write every input here, clear in. Okay, and then wire we have basically from W0 to W1 to W2 to W3 to W4 to W5. Let's see how many wires we have. Let's see, up to W7. Okay, W0, 1, 2, 3, 4, 5, 6, and 7. Up to 7. Okay, up to 7. W6 and W7. Okay, so now we have to call either we can call all my components in sequence, or either we can call my components in a concurrent. That is, we can call any gate anytime. Okay, it will not create any issue. Okay, so for information I will call this half adder clear. Okay, so here in schematic you will see the name is half underscore adder underscore clear, but in coding we have designed with the name of HA underscore clear. HA underscore clear. So as we are calling the gate with the help of the gate like AND, OR, NAND, NOR. Similarly, we will call a half underscore clear. Okay, and then what is that instance name? Instance name is I have given the instance name or not? Okay, U1 and U2. Okay, U1 and U2. U1. Now the important thing is here that in half adder underscore clear, you have started with sum. You have started with output. Please remember, if you have started with the input, you have to call first input. If you have started with the output, you have to call the first output. Okay, so you have to first call the output. So what is the output of my my U1 is W3 and W4. The output of my U1 is W3 and W4. This W3 is mapped with sum and this W4 is mapped with Cout. Okay. So W3 and W4. Okay. Please note, total number of components, total number of input and output is 5. 1, 2, 3, 4, 5. You cannot write more than 5. You cannot write less than 5. You have to manage the all input and output and position also. Okay. So position of clear is the last, not the first or second. If by mistake if you have written the first, second or third, it will give the logical error. Okay. So I will now first write this A in and B in. That is, so what is my A in is input is W0 and W1. Okay. W0 and W1. Again, I cannot write the clear in. Why? Because clear in position is fifth, not third. Okay, so I will write here W0 and W1 and then clear in, because clear in position is my last, fifth one. Again, I will call half adder underscore clear, my second one. Okay, so this is my second one, U2. So what is my output of my this U2 is W5 and W6. W5 and W6. U2, W5, W6, and my input is W3 and W2. W3 and W2. Okay, W3 and W2. W3 and you can change the position of W2 and W3, but you cannot add a clear in between or before. Okay, if you do it, you will get a logical error. Every time I am telling you. Okay, now you can start calling all the gates one by one. Okay, gate 1, gate 2, gate 3, gate 4. Okay, gate 4 is missing. Sorry, this is my gate 4. Let me complete it. G4. This is my G5. G5. and this is my G6. Okay. Okay, save it, and please make sure that you keep on saving. If you don't do it, and if any case your system is crash, okay. Again, one thing I want to convey here: if you are using the Windows 11, okay, then in Windows 11 you have to make sure that you have to design all the design under a shared folder. Okay, please go through my videos before doing all these things. Right, please go through my videos means this is, let me show you all my videos. uh, See, I am reminding you every time so that you should not face any problem in the future. Okay, if you go to the playlist here, go to the playlist. Okay. mm, okay, I don't know how to open the playlist separately. Okay, but let me click it here. Okay, this here I have shown you the logic building, adder theory, and implementation of this. Okay, this implementation of half adder using the clear button. This one, this video. Okay, in this video, I have shown you that how to. Okay, this system is. Okay, see, here I have shown you that how to install the tool and where you have to design it. Okay, so very, very important. If you don't follow the instruction, you will face the problem. Okay, so here I have clearly mentioned that where you have to basically save your files. Okay, now let's back to the work. So now let's start calling all the gates one by one. Let's make it very fast. So G1 is W0 and A in, G2 is W1 and B in, and G3 is W2 and C in. Okay, so and G1 W0 A in and clear in. Okay, semicolon, and G2 W1 B in and clear in, semicolon. Okay, and G3 W2 comma C in and clear in, right, like this. So let's verify W0 W1 W2 W0 W0 W1 W2 A in, B in and C in, and this clear is connected to all the gates. Okay, this clear is connected to all the gates. Okay, now let's start talking about these three gates. Let's start talking about these three gates. Okay, so and G4 and G4, this, sorry, this is, okay, this is G4, right? G4, what input I am getting at G4? W5 and clear in, W5 and clear in. Okay, W5 and clear in. Sorry. Let me check. Gate is, sorry, W5 and clearing. Output is sum. Basically, output is sum. Output is sum W5 and clearing. See, here you can change the position of clearing. Okay, and after the first, you can change you can write it clearing also. First, don't have any issue. Okay, at the gate, don't have any issue. But at the block level, there is a issue. Okay, then we have a OR gate, or what is the OR? OR is having the input basically a W6 and W4. W6 and W4. G5. Okay. This OR is W7, W6 and W4. W6 and W4. Output is W7 and W6 and W4. Okay. And then you have another AND, is the AND G6, and the output is uh, C out. Basically, I have mentioned here count. Okay, so basically I have to write it here C out. C out, not count. Okay, so this is C out. I think, okay, this is clear. Fine, this is clear. So C out is W7 and clear. C out is basically W7 and C out is basically W7 and clear. Okay, so your code is done. So just remember it. Just think that if we have a single code, two block code, it's taking too much time. Okay. Again, we are not making any logic. We are just learning how to connect the different block. If you don't learn this, you cannot know that how you cannot say that you know the completely Verilog. Okay, so my objective is through this initiative, at least I should help you to understand the more syntax and more approach and more modeling. Right, now let's simulate it again. If there is any error, okay, see, this full adder is now made up of two half adder. If there is any error, okay, it will give the error. For example, if I forget I here, clear it, okay, save it, tool will automatically take you to the error. Save it, right click, run, check syntax. Tool will automatically take you to the, okay, no, oh, sorry, I have selected half adder, sorry, I have to select the full adder. Okay, no, not possible. Okay, so here basically tool is not giving error, but this is not possible. But when I'm going for simulation, I'm 100% sure this will give the error. Okay, oh, my tool is hanged, I think. Oh. Okay, so this. Let me go for the simulation. Let's see what happened. See, you are getting an extra clearing signal. Okay, extra clearing signal, because here you are getting ion and here you are getting without ion. Okay, so you are getting an extra. clear in signal. Okay, this is basically a problem. Okay, you should not get this extra clear in. Okay, so that means there is some mistake. So I will again go to the code. Okay, where is my code simulation? Okay. Oh my. Okay, so what I'll do here, I will add the ion here. Okay, and I will see that I'm not getting any other problem, right? Clear in, clear in, clear in, clear in. Okay, see, here also I have chosen I have written the clear. So another extra signal will generate here. Okay, so this is again a problem in the simulation. So I have to write it proper name. Okay, and then suppose that I forget to write I here. Okay, then let's see what happened. Check syntax run. Then tool will give the error. What is the error? The B in is not a port. Okay, because you have written here B in, but you have not defined in the input. Okay, so that is why the error will come. B in is not a port, and here Bn is not defined. So that means there is some problem at Bin. Okay, so writing the code is important, but to understand the error is also important. Okay, now let's simulate it. Okay, run. Okay, now minimize it. Now put your sum in the last, C out in the last. Okay, your A in, B in, C in, and your clear. So if you want to remove the clear, you can remove the clear. Okay, you can remove the clear, select and remove it, and then A in 1, B in 1, and C in 1. So you know that when all the three inputs are 1, your output is 1, 1. But if clear is your high, okay, if clear is 0, you cannot write it. See, your output is 0. That means my clear is working properly. So if you disable the clear and 1, 1, see, your output is coming 1, 1. And if you take any one input from 1 to 0, your output is your sum 0 and carry 1. Sum 0 and carry 1. And if you take one input 1 and another input is 0, means that your A is 0, B is 0, and C is 1. Then your sum is 1 and carry is 0. That means you have designed the correct. Okay. So in this way, basically, we can write the code. Again, this is not a code where you are basically building the logic. Okay, this is just you are helping, just you are basically understanding and how to connect the block. Okay. uh, so okay, so what is my plan here? See, I'm helping you to understand the digital. Okay, along with digital, I'm also helping you to understand the HDL. Okay, there are some things which you can make with the help of digital, but you cannot do everything with the HDL. Okay, like your some complex project, sign calculator. Okay, then your LED blinker, then you have a uh, digital clock. Okay, this is all you can do with the help of digital, right? So whatever you will design with the help of digital, with a schematic design, okay, with a schematic design, whatever your LED blinker, your sign calculator, your digital clock, your stopwatch, okay, your stopwatch, or it is up to you. Basically, you want to design all, you can design all. If you have started thinking from first year, second year, you have a lot of time. You can design a lot of things. Stopwatch and algebraic, and geometric. Okay. So whatever you have basically designed, so this time calculator have, I think, maybe have 7 to 8 blocks. This LED blinker also having this 7 to 8 blocks. So these three projects are basically a sequential project, and this calculator and algebraic is basically a combinational project. Okay, so if you have designed any one, okay, if you are with me, and if you have designed any a single project with me, okay, and if you are expecting the certification from me, then you have to basically design your, you have to complete the project in terms of gate level also. Okay, gate level also. I will show you one project later on, that what is my idea. At least I want to show you how to call the block by block. Okay, I will show you how to call, like today I have helped you to call the 2 half adder to make a 1 full adder. Okay, in next class I will help you how to call a 1 bit full adder to make a 4 bit or 8 bit full adder. Okay, so once your 8 bit full adder is completely designed, okay, then you keep it one side and then you design, then we will go for the other circuit. Okay, so this any one project, okay, we will help you to understand everything. But currently, as I mentioned, that I'm working on sign calculator first, so I'm designing all the different components. So we have designed through schematic. Through schematic, we have completed only up to the 8-bit adder. Okay, so similarly, I will show you how to make the 8-bit adder to till the gate level. 8-bit adder using the gate level model. Okay, so this is my idea. And if at bigger picture, what is my idea is, I will show you one approach or roadmap which I have created next class. But what is my idea is, along with digital plus HDL, and through HDL you will start controlling LED, SSD, LCD, UART, keypad, and VGA. Okay, so these are my interfaces. Okay, these are my interfaces, and some other interfaces like Ethernet, Ethernet, so Ethernet will be very high. SPI, okay, I2C, right? Uh, ADC, inbuilt ADC of inside the FPGA, okay, to make a temperature sensor. Okay, SPI, I2C, ADC. Then you have very advanced Ethernet, very advanced code. How to use the RJ45, that is the Ethernet port, Ethernet, and USB. And one I miss here, basically between keypad and VGA is PS2 port. So guys, if you are really have an interest to make a career on FPGAs, okay, if you design all these things, Okay, on FPGA. Okay, on FPGA. No one will stop you to take the internship. No one will stop you. Everyone, if if you complete till 6 semester, okay, till 6 semester, if you have done, or maximum your 7 semester, if you have done at least some 60-70% part, okay, 70-70% part, no one will stop you to take the internship. Okay, so but now the idea is how I'm going to present all these things. Okay, what things I can present, like up to what level I can help you. So to understand this interfaces, you don't have to do with schematic. Till schematic you can do here. You can control your schematic. You can control this LED and SSD through schematic. Okay, through schematic, but not through schematic. Okay, but not through coding. So all these LCD, start with LCD, UART, keypad, PS2. Okay, you have a better understanding of HDL, either Verilog or VHDL. And through this Verilog and VHDL, you can control the FPGA. So why you should choose us? Okay, because here in now it is not like that. This is a new and which is totally controlled by me. It is not like that. I am the only owner of this. No, you will find these things separately. Okay, many people have designed many things. You will find these things in many portals. Okay, but here the question is either you are getting the connection or not. So the best advantage of learning these FPGAs with me is that you will get the connections. You will get the connection. Connection means how we have started with Verilog first year. You are in first year, right? How you started with Verilog, sorry, HDL schematic. Then in second semester Verilog. Then in third semester, your good level of connections, like you started working on LED, SSD. Fourth semester you have chosen this. Fifth semester you have chosen this. Sixth semester you have chosen this. Okay, so in this way you can basically do it if you are uh, very interest very interesting or very or I can say if you are very interested to learn all these things or want to become a part of the hardware industry. Okay, so this is one basic things I have told you. Okay, this you should follow, and suppose that after 2 years, 3 years, I have some hundred number of students are with me. Okay, then I can go to the company and say, "Hi, I have 100 people who knows all these things. Please conduct the interview." Oh, they say, "Oh, great, you have 100 number of people. I required one engineer. I required three engineers." Okay, they have a better understanding. I will call. Okay, this is what I am doing here. Okay, but I am doing with the limited people, only 5, 10, 20 people. But now at a bigger picture, if I able to help you to get all this data in one platform, okay, from writing of small half adder code to the writing of USB, Ethernet, ADC, I2C, SPI, just imagine what will be your level. Okay, so this is all my idea, my approach. Stay with me. Okay, please share my thoughts to your friends that if you want to learn the digital, Verilog, analog, soon I'm going to start embedded also. Come and join my community. This is the community of yours community, not mine community. This is your community, and India is looking for more engineers in future. Okay, there will be a time will come when every company is going to hire, but if they don't have a resource ready on the basic fundamentals, basic hardware fundamentals, basic language fundamentals, then it will be a tough for them to get the good resource. Okay, so this is all from my side, and as I mentioned previously also, please make your schedule, give at least 30 minutes to 1 hour daily, during your college hours, and if you are free from your college hours, that is after sessional or after semester, at least give 6 to 8 hours. Otherwise, the whole idea will be of no use. Okay, so be focused, be disciplined, and stay in touch. Okay, thank you everyone. Jai Hind.